Related rates problems can be really hard, but this one has a really cool trick for solving it. It says an ice sculpture in the form of a sphere melts, it's getting smaller, in such a way that it maintains its spherical shape. The volume of the sphere is decreasing at a constant rate of 2 pi cubic meters per hour. At what rate, in square meters per hour, is the surface area of the sphere decreasing at the moment when the radius is 5 meters? Lots going on here. We've got the sphere itself that's melting. We can draw a little picture if we like. It's got a certain radius. Its volume, of course, depends on the radius. It's given to us to be 4/3 pi r cubed. And its surface area, which is also given to us, is also dependent on r. It equals 4 pi r squared. And all these quantities, the v, the s, and the r, depend on time t because this sculpture is melting. It's getting smaller. We can then differentiate in both equations with respect to t using the chain rule, keeping in mind that r depends on t. With the v equation, when we differentiate, we get dv dt equals, bring the 3 down, 4 pi r squared, but then don't forget to differentiate r with respect to t like that. And with the s equation, we can differentiate with respect to t and get ds dt is 8 pi r times, once again, by the chain rule, dr dt. Now, what's the cool trick for solving this? The cool trick is to notice that both of these right-hand sides are pretty similar to each other. In fact, we could take this right-hand side and through a little trickery, write it as 2 over r times 4 pi r squared, double check, 2 times 4 is 8, and r squared over r does equal r, times dr dt. And then we can use the fact that this quantity, dv dt, is 4 pi r squared dr dt, and make a replacement. Replace this quantity here with dv dt, so we get 2 over r times dv dt. Now again, dv dt is constant. This is melting at a constant rate. It's getting smaller, so actually dv dt is negative 2 pi. So we can replace dv dt with negative 2 pi and simplify this to negative 4 pi over r. And then to finish the problem, we're after the rate of change of the surface area. How fast is it decreasing when the radius is 5 meters? Go ahead and replace r with 5 to get negative 4 pi over 5. That's the rate of change of the surface area with respect to time. What's the rate at which it's decreasing? That would be positive 4 pi over 5. A is the answer.